Oh. Hey guys, see by that message? I'm not going to be dealing with a car today, but instead something electronics related, kind of automotive related. So if you came here for some car content, go look at some of my previous videos. Trust me, I'll be back working on cars in a couple weeks. Hey guys, welcome to another episode of Afternoon Garage. What am I working on today? Something weird. I purchased a traffic light. Look at that. Who knew that they were so big? I can't believe these things are, well, they're with the surround here maybe 4 or 5 feet tall. It uses lights that are bigger than your head. Look at the size of these things. These are all LED. These are very, very inexpensive for what they are. There's a lot of engineering in these things. You can see these things from a mile away, and yet they're still, this one's 12 watts. So I'm gonna make some yard art. So the goals here with this project, I'd like to have something that plugged into the wall. 110 volts would be good. Another thing I'd like to have is everything's better with a remote. So a remote control to turn on, and I really want to have it do several different things. I want to have it cycle, and I want to have it probably all come on. So that means I'll need probably 2 channels of a remote, and another thing that's a requirement of mine is just to keep it simple. This doesn't need to be very complicated. I realize there are many ways to do this. These are AC lights, meaning you can just plug these spade connectors right into the wall. They'll turn right on for you. So the thing is that I see that there's a little array of LEDs right in here. That's why the current is so low. So what's going to be inside of here is there's going to be some kind of a rectifier circuit to rectify AC voltage into DC, and then something that steps it down. I don't want to get into these at all. I don't want to take these apart. I realize I probably could and run them, actually switch low voltage. It'd probably be really safe to do that. But I want to keep these intact so I can just plug them in, and if one goes, then just replace it with another. For starters, I want to work with one of these. It's an Arduino. So I've built a couple projects with these in the past. This is the Arduino Uno. Probably overkill for what I'm doing, because what I'm doing is I'm switching a few lines, maybe an input, some outputs, and some timing. Really not a very complicated project. We'll go through the code and we'll get this thing working first, just to make sure that this is something we're going to be able to do with this. And once we get this switching and everything's good, then we'll start to add more and more components till we get the high voltage in there, build a prototype, and a bunch of traffic lights taken from some upgrades that were done in what great yard art, recycling traffic lights. So here we have 3 versions of the Arduino that I got. This one here, it's kind of a generic Arduino. This Arduino here can be purchased relatively inexpensive for maybe $10, $12. I guarantee you it's right out of China, and it's a copy of the Arduino Uno R3. This Arduino I ordered here said it was supposed to be an original. Well, when I received it, I noticed that the back of the box was blue. Now, an original Arduino Uno R3 is going to be green. Let's open that up and see what we got here. Wow, that looks pretty good. So it says, unlike this one actually says Arduino Uno. So it actually has the Arduino stamp on it, whereas this one doesn't have anything on it. But you can see the placement of the parts are all the same. However, I know from a website that I've gone to that this is a copy. So if you get a genuine Arduino, it should look something like this. Should have like a serial number, a part number. Let's open it up. There you go. So, this is much different than either of the two that I had here. Comes with this little plastic holder. I guess that would be pretty good for just mounting the bare Arduino onto something. Gives you a couple different screw holes here. That's kind of neat. So that's something you don't get with the copy here. Another thing is, you can see, it's definitely blue. This one's green. Once again, there's a website you can go to make sure you have the genuine unit. If you really want to support the open source Arduino product, make sure and purchase a genuine one. They're going to probably cost you $22, $25. This one here was, I think this was about $18. So even though it had the Arduino logo on it, it wasn't the real thing. So as you know with anything, you get what you pay for. And hey, if you're not paying $25 for this and it doesn't look like this, you're not getting the real thing. This is the main processor. There's a power input. You have a USB for programming. It's one of the older style printer type ones. So you have a series of digital pulse width inputs and outputs here. 13, a ground, an analog reference. Then you have power over here. You can pick up a 3.3, a 5. Your input voltage, in this case, put 9 or 12 volts in here. And make sure you pay attention to the polarity. And then you have analog inputs in. So this thing's quite amazing. You can do a lot with this. Besides it being programmable, it doesn't have a lot of memory, but you can connect modules to this to make it do all kinds of different things. For instance, you can have a module, a joystick module, and this will, you want to use something like this, it uses 4 potentiometers, excuse me, 2, and you can interface that with your project. Here's that microphone module. Looks like it has a little amplifier on it. This looks like some kind of a tilt mercury switch with an amplifier, maybe a trigger of some kind. This is some kind of a flag where you can run something across there to have it sense. They have all kinds of level sensors. Here's the Arduino development board where you can plug this right in here, and you can either breadboard or use your breadboard here, or you can hardwire components right on top of this thing. That's great. Battery backup modules, buzzers, potentiometers. These are all individual monitor modules. This actually is a looks like a switch. It's probably a BCD type of switch to select between different things. This is a 3-color LED module similar to what they use on LED displays. Infrared modules to operate your TV. Yeah, it's endless. Tricolor modules. You can even get full displays like this one and have your readout right there, depending on what you want to make it do. This is very customizable, highly programmable. The only thing is the requirements, the addressability is limited. If you're doing something like a bit bucket routine, which requires a lot of memory, it's probably not going to work very well for you. But for what we're doing, all we want to do is we want to switch between 3 pins. We want to kind of have 2 software modes, and then switch between 3 separate pins. So we're going to have 3 outputs and a digital input to switch the LEDs on and off. Use this to drive some type of high current circuit that'll eventually drive our LEDs. So let's get into the code of the whole thing. First thing you need to do is get the software off the web. So go Arduino, download, and then software there. Then there's a couple different versions. I'm going to choose the Windows version here. And then they want some money, so you just download. And then click on Go. It's a free program. It'll start to download and follow the instructions for setup. Here's an example of the code that I use to load into the Arduino. So you can find different versions of this on the web. I kind of made it my own. So basically you have your variables up here, your basic functions here, where you define your outputs and your inputs. This defines your variables, how long you want things like the delay green, delay yellow. This is 5,000, that'd be 5,000 milliseconds, so we want 5 seconds. Then you have a loop down here, which just simply just goes in loops and loops and loops. And then you can establish what a green light means. So you digital write the pin green high, digital write the yellow low, digital write the red low, and then that gives you a green light. The program will reside in this loop here. After it sets everything up, it'll display the green light, and to have the green light, of course, you need to set these pins. Then it gives you a delay. It'll turn on the yellow light, and it'll have a delay, and then the red light and a delay, and then a loop. Let's wire this up on our breadboard to the Arduino and see if we get the flashing lights, typical traffic light, green, yellow, and red, with these appropriate delays on these outputs. Well, I've drawn up a schematic for this, so here's the Arduino, and you can see it uses outputs pin 2, 3, and 4 with a 220 ohm resistor with these 3 LEDs with a common ground. Let's wire that up and see how that works. So we're going to plug it in, watch the Arduino boot up. Green, yellow, red. Perfect. So all I've done is I've taken the 3 outputs, run it through a current limiting resistor. It's about 220 ohms since it's 5 volt output. So what it does, so Arduino switches between 0 and ground and 5 volts. And then run it through a current limiting resistor to the LED. All right, well that worked pretty good on the bench there. So what we have is we have a basic traffic light which will cycle through each one of the colors, and that's pretty much all it does. So what we want to do is we want to change a little bit, and we want to designate an input pin here in which we can toggle an input and change a state. So there's really no interrupts. There is interrupts in here. I'm really not quite sure how to use them, but that's okay, because what we can do here is we'll just contain what we need within the loop. So we do the same thing here. You set your variables up. In this case, we have an addition of this input pin. Then we have another variable called switch state. You want to define these variables before you go and call them. So once again, we have the different pin modes. The input pin here is 0, and it's defined as an input pin. The rest of them are outputs. Once again, we define what a green, yellow, and a red light is. You can see the loop here is in a different spot, and that's okay. What I want to do is I want to do the same traffic light thing with the delay green, green light, yellow light, red light, yellow, green light, yellow light, red light, and then what I want to do is I want to have all the lights come on when a switch is pressed. So if something changes state on the input, I want it to detect that and then turn all the lights on, which is what this is here. So I wrote each one of the lights to high. And then, so basically what happens is it looks at the switch state, digitally reads the input pin. So if you have this input pin is toggled to high, then it'll go and run this code. If it's 0, it'll run right through here. So, and it'll do that, and then it'll go through and loop again if it's 0. But the second that changes, it's going to change the mode and do the other. So when it goes high, it's going to say, oh, the switch state is 1, so it must be else. So it'll drop down here and then run this code here, which will have all lights on at once. So just kind of a basic way to do it. As I said, there's no interrupts in this thing. I really wish there was. It'd probably make it a little bit easier to do. But nevertheless, this is kind of an easy way to do it too. Especially you can see the code here is almost nothing. I'll put the code down in the comments section, as well as on the Afternoon Garage Facebook. Here's a schematic I drew up with the Arduino with the addition of the mode switch here. So you have the basic same Arduino circuit we had before with the green, amber, and red lights and the common ground. And then on pin 0 here, I've added a mode switch. So this is going to be high normally, and with the mode switch, it's going to ground and it's going to change states. Run that other line of code. Let's build this circuit, see if it works. This mode right here is constantly looping. It loops, it loops, it loops, it loops. I think I have it looping every 10 milliseconds, I think. So when you reconnect this to ground, it's going to send the signal to the Arduino to run the other set of code that I had on here, which is the cycle code, and then it'll start it cycling there. Very nice. This is something we can work with. Now we'll take the outputs of here. We'll connect it into the optocoupler through a current limiting 1K current limiting resistor, and we'll run that, and we'll see if we have any issues there, and we'll move forward from there, and eventually we'll put some high voltage on this. Be careful, folks. So this is what the high voltage circuit looks like. Receives 5 volts from the Arduino, switches this optocoupler here, and switches the base of this NPN transistor, which then drives the individual traffic light lens. Gets its power from 110 volts AC, rectifies it, turns it into DC, and then it's switched by that NPN transistor right there. Let's build this up, see if it works. Just a word of warning here. This is really high voltage. You stick your fingers on this in the wrong place and you're going to regret that. So just be careful. So here we have the circuit, the output circuit. So we have the optocoupler there, our input resistor, that'll get switched with 12 volts. 12 volts on this one. I think the Arduino. I'm never going to learn that. The Arduino is supposed to get is 5 volts out. So what we have is we have the input to the bridge rectifier. There's our 4 diodes right in there, and so that's our input. And then this is our output. This goes to the collector, and this goes to the other side. This is according to my sketch that I had made. So what we're going to do now is we're going to hook this up and see if we can use the optocoupler to switch the power transistor. We'll bring in one of these. Once again, be mindful. It's going to be at least 120 volts. So we'll put AC power to it. That's good, no smoke. And then what we'll do is we'll ground, or we'll energize the optocoupler. Oh, and the light comes on. So that is our high current switch. We're able to take 12 volts and switch a rectified 120 volts with it. No problem. Well, I took that Arduino circuit that we had with the mode selector and then left the LEDs on the board so we could actually see what it was doing. But then I tied in the high voltage circuit for each individual light. So each one has its own rectifier here, and powered by 110 volts and 12 volts. I think I've taken a proof of concept. I think I'm going to skip the testing on this last one, since I already know from using this box here that the switching circuitry is going to work just fine. So I think what I'm going to do is I'm going to grab a perf board and start putting some parts onto a perf board, and have each individual circuit be independent of each other. So that means 3 LEDs, 3 optocouplers, 3 drivers, 3 sets of rectifiers, We'll put that together on here and see what we end up with. Okay guys, this is it. I built this up. This is the piggyback board that goes on the Arduino. Say it right. Not very happy with this. You can see it has all these diodes in here, the 3 driver transistors, and then kind of just a random pattern for the LEDs. I'm not really happy with this. There's lots of jumpers all over the thing, excluding the hookup wires here. But still, there's even jumpers on the top of the board. It seems that I could maybe lay this out a little bit better and maybe have the LEDs in a line to maybe make this thing a little easier to construct. This took me probably 4 or 5 hours to lay this out and set it up, and it does work. It's just that I think it could be much more efficient than it is. I think I'm going to try to eliminate some parts here. I was going to eliminate the LEDs, and then maybe that's not a very good idea because you kind of want to see what this thing's doing. And I think maybe what I'm going to do is I'm going to try to pull these 3 rectifiers out there, and I know they're separated right now. It's kind of what I wanted, but maybe what we can do is run it off of just one rectifier. I ran the calculations. The LEDs draw 9 watts, so that'll be 27 watts total. So the current is at 170 volts, is probably right around 0.2 of an amp or something, and these diodes are good for an amp, 1000 volts. So it should work, but let's breadboard it on the bench and make sure, and maybe even hook up all the loads to it and see it cycle and see it do something finally. Yeah, so that prototype I built, well, it had a lot of parts on that board, and I'm after eliminating some of these parts. So you can see what I did here was I took those rectifiers out of this circuit and I kind of shared them on a common bus here with just this one rectifier here. That's going to eliminate 8 parts and make things a lot more easy for me as far as laying this thing out and making it make sense. So I think what I'm going to do is build up the board at the bench, give it a test, and see if it'll run off of one rectifier circuit here. Here you can see we've added this 3rd circuit in here. So we have the Arduino switching the outputs to the LEDs, just driving the LEDs to ground, and then a 1K ohm resistor to the optocoupler circuits, which is then driving the output circuit. So it's very simple. So all we really wanted to do is to see if we could have a single rectifier circuit instead of what we have here, what we made here, which is, man, that's a lot of diodes. So I think one thing also we want to check, we want to probably pull this output here so that we can get all of the LEDs to turn on at the same time to make sure that this is going to be able to handle the load. There we go. So I've switched the mode. They're all on at the same time now, and now what we're going to do is we're going to connect all our individual lights and see what happens. All right, guys, we got it powered up. As you can see, it's working. So the circuit works with one rectifier. So what we really want to do is we want to disconnect this so we can make sure that they all 3 will light at the same time and we won't have any smoke when you want all the lights to command on. And there they go. Boy, those are bright. They look like they have pretty good intensity. I think we'll leave it there for a little bit. Make sure that it'll be tested for a few minutes. Make sure nothing's getting hot.
24 hours later.
It's time to move on and build something else other than this thing. This is terrible. So too many parts, not laid out very well. Not really sure what's going on there. Too many jumpers, too many points of failure. So I'm gonna build another one. worked out pretty good. Now that I know that everything works on here, I'm gonna start refurbishing those metal housings that I got. I got those at a swap meet, relatively inexpensive. They have a lot of corrosion on them, but this was the key into making this whole thing work. So if this didn't work, I was just gonna have to keep on figuring out what I was gonna do until, well, I had a solution. There's a lot of other things on the market for purchase that you can actually just wire right in, kind of do the same thing that I just did here. However, they're not programmable and they have parts that wear out. Specifically, they have dry contact relays in there, but you know those contacts, they come together and come apart. They only last so many times, so you know, I wanted something that's gonna last almost forever. So we'll be going over that next week. Till next time.